talk about dependency injection and inversion control in Spring Framework. I'm assuming that everybody knows how to do basic things in Java, how to create classes, how to run a simple program, how to create objects from classes that's necessary for running simple programs, simple Java programs. And that is all I'm assuming. I'm not assuming any previous knowledge of the Spring framework. However, this is a very basic concepts of the Spring framework. So we'll actually be working with Spring framework, but I will not assume anybody to know anything about Spring at a time. So this is where you download your Spring tool suite from. I'm showing this the first thing because it takes a while to download, and we can talk about the concept while this is still downloading. So this is a picture of my kitchen where I have a new fridge, an old cabinetry, new countertop, new backsplash, new floor. But right now I'm going to talk about the fridge and the cabinetry, not anything else. You can see that the fridge is brand new. It was ready-made, bought from a store and plugged in where it should be plugged in. Whereas the cabinetry is custom built. It was built when the house was built. And even though I wanted to change it, I did not, because it is custom made. Ready-made ones will not replace it, will not fit well into this kitchen. It will either be very expensive or it will not be done, or it cannot be done. So I just took the fridge out from here. You can see that, if there's no fridge here, anybody can buy a fridge and plug it in here. Or in other words, I can say that anybody can inject a fridge here. So guess what? I already talked about dependency injection. So the kitchen is dependent on a fridge. A kitchen cannot be created without a fridge, or it will need a fridge to function well. So that's dependency. My kitchen depends on a fridge. And dependency injection is where somebody gets a fridge and plugs it in where it should be. Inversion of control. We haven't talked about this yet, but it's pretty easy to understand with the kitchen scenario. So a fridge needs to be plugged in where it belongs, or where a kitchen needs a fridge. But inversion of control is about who is going to do it. Either the kitchen can go and find its own fridge, or the house owner can go and find a fridge, or someone else can visit the house and see that there's no fridge, and they can come and get a fridge from somewhere and plug it in. So there are three ways it can happen. So when the house owner does it, that's typically what happens. When someone else does it, that is rarely done. That is not that common, but it's doable. And that is when it is inversion of control, because instead of the house owner finding their own fridge and plugging it in, someone else from outside is seeing that there is a need for a fridge, they're getting it and they're plugging it in. So in terms of programming Spring framework, usually the container or the framework does that job. They find that where there is a need for an object inside of an application, it goes, finds it, and plugs it in. So that's how the control is inverted, because usually or traditionally, the application programmer creates objects, maintains them, destroys them as needed. Even though Java has its own garbage collection method, which is better than older programming languages where the objects just live forever unless the programmer destroyed them explicitly. Even then, an application program can end up creating too many objects and thus using too much resources that they don't need. If the container maintains a pool of objects, just like, imagine that there is a pool of fridges. When you need a fridge, you can check one out and use it and return it or recycle it, or unless you absolutely need a new one, even then you can request it from the container. So the container maintains a pool of objects that applications can check out from. So that is inversion of control. So there are many advantages of dependency injection and inversion of control, which is pretty obvious. If my kitchen can be built somewhere else in a factory, my application or my kitchen doesn't have to take the trouble of custom building a fridge for itself. And they're very loosely coupled in that the fridge can fit in any kitchen where the size and the outlet are available, matching. They have to match, of course. But then this fridge can be built, tested outside of the kitchen. A kitchen can use fridge of any brand, uh, so long as the size is fitting. Also, in some cases, a used or rented appliance can work. That will save resources. Similarly, if there is an existing object in the object pool nobody is using, an application just get it, use it, and send it back, recycle it when they're done. So these advantages are pretty intuitive and obvious. I'm saying it again because this is the core concept that we are going to talk about here. I'm comparing the objects with appliances, the framework with the factory, and injected with plugged in. So from the kitchen analogy, it's pretty obvious why it is important or helpful or advantageous when the container does the job of creating, maintaining objects and injecting them wherever they're needed. So this is another diagram that says that application classes are fed into the container, configuration metadata is fed into the container, and the container generates the finished product or the software application. The advantage is that the application programmer can focus on just the business logic. Then what is configuration metadata? It says that what kind of objects an application may potentially need, whether they want it new, brand new, or used is okay from an existing pool. Also, what is the dependency among these objects and all that kind of stuff, which is completely separate from the application logic in Spring Container or in Spring Framework. Now, talking about configuration metadata, it can be done in three ways. You can have a separate XML file where you can write all those information in the XML language, but the disadvantage is that one has to know XML. The advantage is that it's completely separate from the application. In a later development, something called annotation was added. So in a Java file, you can annotate certain classes and things to indicate that they have what is their connection with the metadata. For example, if you annotate a class with, say, component, that means it's a component, that's a class from which an object can be created that that application will need at some time. Obviously, why would you have a class unless it's a component? But that is not the question. The question is that if you mark it as an application, I'm sorry, component, then it will be known better than it is a component, and it will be clearer at a later time. So when you have annotation and XML, if there is any conflict, the XML will override the annotation. And some may argue that when you do annotation, you are not keeping your application and configuration separate completely. But it makes things easier for larger projects. Otherwise, the XML file becomes too large and unmanageable with too many objects. So some configuration data in Java file is actually not bad. And in a later even later something, the latest and greatest is doing all the configuration in a Java file using annotation. Here, we don't have any XML. The advantage is that nobody has to learn XML. Learning Java is enough. But once again, the boundary between the configuration and the application is not maintained enough here. But still, it is popular because it makes managing easier, larger projects easier. What are beans? We hear bean a lot in connection with Spring Framework. Beans are nothing but objects. Those are created, managed, and destroyed by the container. Now our Spring toolset has downloaded completely by now, so we can just click on the green icon and it will start working. I started with a Spring Boot application because in Spring Boot, it just configures itself. There is no elaborate configuring to be done for the IDE to work. So we can go straight into it. Just say launch. Now go to the file menu and try to create a new file. Choose a Spring Starter project. That will create a starter project for you. Okay, choose the latest version of Spring, say finish. Now we have our package. This package is called com.example.demo and it's under JPA demo-2. It was created as a JPA project because I wanted to do JPA project that allows database access. But that's how the JPA name came here. But this, I'm not going to do database access here because that is not the purpose of this demo. We'll just use the skeleton that was generated for us. We'll have to remove the add Spring Boot application in line 6 because that is not what we are going to use. And I'll also have to remove line 10 because we are not going to run this as a Spring application here. So I changed this main class in JPA demo application because that is not we have to have some our own logic inside of this class. So inside the main method, I wrote application context CDS and new application context, which is application context is our container that's going to manage our bins or objects. And I passed a Spring config class into it. Now I have to mention here that fridge config is kind of a misnomer. It should have been app config or just config because it is going to configure both fridge and kitchen, but it still works the same. So in line 11, I declared an object K of type kitchen. And I request, instead of creating my own instance of kitchen, I ask the container to provide me a bin of the kitchen class. And then in line 13, I called a method on the kitchen class, which really is a method from the fridge class, but I really didn't refer to the fridge class from here or any object from the fridge class from here at all. So this is our fridge class, which is pretty simple. It has a private string variable message and getter and setter for it. So it says we are setting a message and getting that message. That's all. Now next I have the configuration class. Here in line 6, I had to use an annotation configuration to mark that this is a configuration file. I declared 3 bins, fridge, and then a kitchen with a fridge being passed as a parameter, and another method that just calls a kitchen constructor, a blank kitchen constructor, and creates a kitchen without a fridge. So this is my kitchen class. It also has a variable fridge of type fridge. It has default constructor and the constructor with a fridge and getter setter method for fridge, and also an additional method that says get fridge method, where I'm setting the message to be Maytag because that is the brand I want. Now hard coding like this is not the best idea in Java programming, but it's okay for this example. Now it's time to run the application because it's complete. It was pretty simple. Now I go right click on com.example.demo in my package. I say run as Spring Boot app and it runs. Say OK and it produces a message Maytag. Now you see a word, an annotation in line 12, auto-where. I'm going to talk about it soon. This is auto-wearing of dependencies. So your container or your house needs a kitchen. Now kitchen needs a fridge. Maybe fridge has a shelf missing. They all find their dependence by themselves. Kitchen finds a fridge finds the shelf it needs, and that is called auto-wiring. So in terms of the container and bins and objects, Container finds where a bean is needed. Container supplies the bean, but before that, it has to assemble the bean by finding all the dependent beans and assembling, much like, you have to assemble a fridge outside of your application or outside of your kitchen, and then bring it in and plug it in. So auto-wearing dependency, like I said, the container finds the dependencies and plugs them in where needed. Now there are two ways of finding dependencies, one by name and the other by type. In XML files, the default is by name, and in Java configuration file, the default is by type. And that's why you notice that I didn't mention anything about type, name, etc. because when kitchen needs a fridge, Java configuration find is by the type. Type being that is the type of appliance. It's not a stove, it's a fridge. So there are four ways or four places to put your auto-wearing instructions. One is no auto-wearing at all. And then you can auto-wear the attribute, the fridge attribute in the kitchen class. You can auto-wear the constructor, or you can auto-wear the setter method. Here, I just summed up my application details. We talked about it before, but I just put it in one place again. Now, the kitchen class and fridge class, those are components. They can optionally be marked as components. And you can create plain old Java objects from them. I just mentioned that here. You hear POJOs in connection with Spring. POJOs are those plain old Java objects that can be created from plain old Java classes like my kitchen class and fridge class. Now here we are back to that kitchen class and talk more about the auto-wear construct. It is on top of the constructor. Here we are assuming that a kitchen cannot be built without a fridge, so we are passing a fridge into the kitchen constructor. And since this constructor is auto-wear, it will find the fridge that fits in it. It will find that fridge by itself. So yeah, the program runs and it produces the result. And you can see that the auto-wear is now in line 5 on top of the fridge attribute. That means here we are auto-wearing the attribute. If there is no fridge, the kitchen constructor will find a fridge. This is doable, but not typically done because it's more resource intensive than auto-wearing the constructor or the setter method. And here we are auto-wearing the set fridge method with the assumption that a kitchen can be built without a fridge. A fridge could be bought in at a later time and plugged onto the kitchen. So we are auto-wearing the setter method. So what did we discuss here? We discussed the dependency injection, which is where the container finds a dependency in an application where the application needs an object, depends on it for to function, it finds it and plugs it in there. Then inversion of control, it's not about what is being done, it is more about who is doing it. When the container does the dependency injection, it's inversion of control because the application is not doing it by itself, it's letting the container do it for themselves, and that's inverting the control because traditionally the application programmer used to control creation, maintenance, and destruction of objects. So in order for the container to manage the objects, it needs some metadata to be provided in the configuration that will talk about the objects needed, whether they're needed brand new or not, whether they're needed by name or type, what are the dependencies among themselves, and those kind of things. It can be done in 3 ways. One in XML, one in annotation with XML, other is in all in one Java file. So the advantages of doing it in XML is it's totally different, totally separate from the application itself. Disadvantage is that one has to know XML. XML with annotation moves some configuration instructions into the Java file, which is more convenient for larger projects. Otherwise, the XML file becomes somewhat unmanageably big. But then disadvantage is that we are not separating the configuration and the application totally. They are getting mixed up to some extent, but that's okay because it's more convenient. And the third option, the latest and greatest, is doing all the configuration in a Java file. So when you do that, once again, we are not keeping your application and configuration totally separate, but the advantage is that it just makes maintaining the configuration file much easier. Now, we talk about another thing about auto-wearing, another construct, another annotation, or another concept, where a bin, or first a container finds a dependent bin, and then a bin, if it has another dependency, a dependent object or bin, it finds it by itself. So that also makes application programming easier. It has its disadvantages. Sometimes a container gets confused with too much auto-wearing, too many dependencies, but that rarely happens. So auto-wearing can be done in three places. Either you can auto-wear an attribute without any constructor or anything getting involved into it. It works, but it's more resource intensive, so it's rarely done. You can also auto-wear the constructor of a class, just like in kitchen class. We can auto-wear the constructor, and if a kitchen cannot really be done or made without having a fridge available, then we do this kind of things because a fridge is a required part of kitchen. We pass a kitchen up, we pass a fridge object or parameter into the kitchen, and then we auto-wear the constructor where the fridge is being passed. There is another way of auto-wearing. We can auto-wear the setter method, like a kitchen can be built without a fridge initially using the blank constructor, and a fridge can be brought in and plugged into it at a later time. So then we auto-wear the setter method that sets the fridge attribute of a kitchen. So these are all the methods that could be done. Those are the ways auto-wearing can be done. Thank you for listening. If you have any questions, please let me know. I would like to hear from you. Thank you for listening. Bye.